Today we're working on lesson 95. This is another test for independence. Just as a quick review, in the previous lesson, we learned that you could test to see if two events are independent if the probability of one does not affect the probability of that event given another event. Then they would be independent. Today's lesson's notes have 4 pages. The first 2 pages are kind of the why this works. So you can watch the first 2 pages. I'm going to use my answer key again because it's a little neater than me writing on my tablet. And then the second video is the last 2 pages of us doing problems. So keep that in mind while you're watching this. So this is supposed to be blank, but I'll explain what I did here. So in exercise 1, it says in the table above, we already know A and B are independent. That's just a given. Kind of like in geometry, you had givens before you did proofs. So part A says circle the 2 cells that are used to calculate the probability of A given B. So remember given? That means that's where we're looking. So those are the 2 things, or that's the row I'm looking at. Label the leftmost cell you circled X, so I did that there, and the rightmost circle you circled Y. Okay, so now when we find our probability, it says therefore the probability of A given B is X over Y. And we already know that these 2 are independent. So we know this is true. The probability of A is the same as the probability of A given B. So now, part D. Box the 2 cells you use to calculate the probability of A. So I boxed this, and I boxed this. And then it says label the leftmost cell. You boxed CX, and the rightmost CY. So then when we calculate this probability, we do this divided by that. And when you simplify that, C's cancel out and you're still left with X over Y. Now fill in the remaining cells. So I did that. So C times X minus X, whatever that number is, would go there. And then Y plus this would give you CY. So we did that. Now it says use the table above to express the following in terms of X and Y. Explain why your answers make sense. Here's the gist of this. You can see my work on the left. If 2 events are independent, that means everything is in proportion because one event isn't directly affecting the other event. Now, what I wrote over here, if A and B are independent, it doesn't matter if B happened. It doesn't impact the probability of A. So we can do the probability of A, and it's going to be the same thing as the probability of A given B. And because it makes no difference, it's the same as the probability of A given not B. It doesn't matter. They're all the same values when you simplify them because they're all in proportion. So now on page 17, this is just reiterating it. When the events are independent, the values in each column of the two-way table are in proportion. And the same is true of the rows. So no matter where you look, rows, columns, everything's in proportion, only if they're independent. So our next example, this can be observed in the following table from the last lesson. So that was where we had, if you participate in extracurricular activities and you know what you want to do after high school. And we knew that one did not affect the other. So they were independent. We had figured that out last time. So what I did here, I found the probability of participating in an extracurricular activity is 800 over 1,000, simplifies to 0.8. Then I did the probability of extracurricular given K. Oh, my pen is taking a break. There we go. So 560 over 700 still simplifies to the same thing. And then the probability of extracurricular given not K. 240 over 300, they all simplify to the same value. Now we could do that same thing. You could do the K first, the probability that you know. It doesn't matter. You get different numbers, but when you're testing for independence, they're all the same number. Okay, now this is going to lead us to another rule to test for independence. And honestly, it's best used when you're trying to solve a problem. It's a little bit easier than making a whole table and figuring this stuff out. So you can see that some things are labeled. Okay, this is the probability of both. This is the probability of A, probability of B. And our total is always a 1 when we're talking about probabilities. So what I did over here was I set up a proportion. So the probability of both over the probability of A, and then probability of B over 1. And I solved my little proportion, and I got this. So the probability of both, the probability of A and B, is equal to probability of A times the probability of B. So this is another way we can test to see if something is independent. Probability of both equals the probability of A times the probability of B.